Alright, today we're looking at Module 1, Lesson 19, Comparison Shopping Using Unit Price and Related Measurement Conversions. Oh, look at that. There's another typo here. Conversions. Okay. Anyway, today, basically, again, doing nothing new. It's just going to be a different look at what we've been working on. Last week, we looked at a ratio table. So if I told you we were comparing, let's do our old standby, Oreos to chocolate chip cookies. We would make our table of 2 to 1, 2 to 4, 3 to 6. So what would you say is my unit rate or my value? Or scale it down. That all means the same thing. So what would you say? 2 what to 1 what? Right. So how can I write that as an equation? What would my equation be to represent the relationship between Oreos and chocolate chip cookies?
2 all equals C.
So 2 times the number of Oreos equals C?
No, wait.
Right. No, wait. Let's fix that.
I think that's backwards.
That is backwards. So how would it be?
O equals 1/2 of a C.
What do I have to do to my cookies to get to my Oreos? What am I doing to my chocolate chip cookies to equal my Oreos?
Divided.
What am I, my 1 to get to 2, my 2 to get to 4, my 3 to get to 6. What did I do every time to my cookies to get to my Oreos?
Times it.
Right, times it by what? 2. So I multiplied my chocolate chip cookies by 2 to equal my number of Oreos. So my equation is 2C equals O. O probably isn't the best variable to use because it looks like a 0, but you know what I mean. So last week we took our table and wrote our equation. Today we're going to get the equation and make a table. We can do that. You ready? Well, if you're not, too bad. Here we go. Highlighters out. Everybody should have their highlighter. So let's read the information that they're giving us. Okay, the ratio of cups of blue paint to the cups of red paint is 1 to 2. So right there I see my ratio. Blue to red is 1 to 2. Right off the bat, I see my ratio. I'm going to highlight it. Which means for every cup of blue paint, there are 2 cups of red paint. In this equation, in this case, the equation would be red equals 2 times blue. But we don't write it like that. We write our equation red equals 2 times blue as R equals 2B. So highlight that. So B represents the amount of blue paint and R represents the amount of red paint. I just realized it wasn't recording when we made the table. But we made our little key over here of blue to red. So we have blue to red. And so if the ratio was 1 to 2, we filled in the first column as 1 to 2. We use repeated addition to fill in the rest of the table. Okay? Let's try it again now. Miss Sipple, sounds like a librarian's name, right? Miss Sipple is a librarian who really enjoys reading. She can read 3/4 of a book in 1 day. This relationship can be represented by the equation days equals 3/4 books, which can be written as D equals 3/4 B, where B is the number of books and D is the number of days. So let's stop and go back and highlight 3/4 of a book in 1 day. So there's our ratio, so highlight it. And here is our equation. Days equals 3/4 of a book. Everybody has that highlighted? So let's make our little key here first. What 2 things are being compared in our ratio? What 2 things are being compared in our ratio?
Days.
Right, so we have days. Whoa. we have days to books. And what do I know about my days to books? Right. In fact, I'm going to switch this around because here it says books in one day. So she reads 3/4 of a book in one day. So what are the two things being compared? Right, so let's fill this in. Number of books, number of days. Anybody have a question with why I labeled each row this way? Where those words came from?
Do you have to do number of, or can you just do books?
That's okay. That's okay. Yes.
Is there any other way to write like 3/4 of a book to make it a little?
Well, since they gave it to us as fractions, we're going to keep it as fractions, okay? Because we're not afraid of fractions. Fractions are fun. You've been doing fractions since like kindergarten. Coloring in little circles and pizzas and things, so you can handle this. So let's fill in the first column. What am I going to put here? What is my number of books in my key? What's my number of books in my key?
3/4.
So 3/4 of a book in one day. I'm going to do the bottom row first, so that's totally easy. If there's a 1 here, I'm going to keep adding 1. Phew, easy, halfway done. Speaking of halfway, that sounds like fraction. So let's do our fraction. Do you like that transition there? Fine. So I have to keep adding 3/4. Good thing I have a margin because I do not want to add my fractions mentally. So I have common denominators? Yes. So what's 3/4 plus 3/4? 6/4. Can I leave that as an improper fraction?
No.
So what is that as a mixed number? 1 2/4, which reduces to 1 1/2. Okay, I have to add another 3/4. Since I want common denominators, I'm going to use that one. 1 2/4 plus 3/4, 1 5/4. Still an improper fraction. So what is 5/4 as a mixed number? Well, this would be 1 1/4 plus the one that's already there, so 2 1/4. So now 2 1/4 plus 3/4 is 3 4/4. Well, what is 4/4? Oops. I got ahead of myself. 2 4/4? That would be 3. Questions? Where did the 3 come from? Where did the 3/4 come from? What did we add?
When they give you fractions and you're going up by the fraction, like say they give you the fraction you, but they give the fraction as a mix.
All right, let's continue. And let's take a look at exercise 1. I like this one. It's about bike racing. Brian and Shanice are both training for a bike race and want to compare who rides his or her bike at a faster rate. Both bikers use apps on their phones to record the time and distance of their bike rides. Brian's app keeps track of his route on a table, and Shanice's app presents the information on a graph. The information is below. So there's Brian and there's Shanice. So if we need to know who goes faster, what do we need to know first? How would it be easier to compare their two what? Their their ratios or their rates to see who goes faster. So taking a look at this table, first let's identify Brian's rate. What is Brian's rate? How fast does Brian ride his bike? How fast does Brian ride his bike?
25 miles in 1 hour.
How'd you get that? How did you get 25 miles per hour. You have the correct answer, but you have to show evidence to support your claim, just like ELA.
Because 1/3 of 75 is.
Well, here, let's look at miles per hour. So if we're looking at miles per hour, he does 75 miles per hour, and that reduces to 25 miles per hour. So we took our ratio, and it's okay that I flip-flopped it because I did miles per hour, so it looked like a unit rate. Let's write this down and leave you some room here because now we're going to compare Shanice next to that. So this is exactly what your homework is going to look like, I think, except for motorcycles. We're going to take it up a notch for your homework. No more bicycles.
Motorcycles is the way to go.
Don't quote me, I think that's what your homework is. Okay, so your homework, so if you're comparing two people, I want to see the work that gets down to your unit rate. 25 miles per hour for Brian. All right, what about Miss Shanice? What does she do miles per hour? This is a graph. What can we do on our graph to find her unit rate of miles per hour? You had your hand up, right?
Yeah.
What are we going to do here?
So the hours is on 1 hour.
All right, so we're going to look at 1 hour.
Then not directly off 10 of the 20, so that means it's probably in the half between them, 15.
Right. But because it's hand drawn, maybe it's 14, maybe it's 16. She used pretty big intervals. Whoever made this graph, her app, used intervals of 10. So it's hard to tell exactly. But right away, do we already know who's faster? Because if she's approximately 15 miles per hour, is 15 miles per hour slower or faster than Brian's 25? Slower. So we already know Shanice is slower. But you know what? Being a math person, I want to know exactly, because I'm a competitive person. I always want to know exactly what it was. So you're right, 1 isn't giving us exactly, it's giving us approximately 15. Is there other information on this graph that could help us?
It says for 2 hours, it's exactly 30 miles.
Okay, so in 2 hours, she does 30 miles. So if you want to highlight this on your graph like I did on the board with red, so that when you go home and look at your notes, you can see where did she get that from? Well, that's where she got that from. Okay, so highlight that on your graph. If you don't have a highlighter, I'm sure the person next to you would be happy to share. So now, let's get that down to, that's my ratio. That's my unit rate. I don't care about 2 hours. I want to know 1 hour.
55, 35.
Okay, and what we get? So it is 15 miles per hour. So I know that Brian is 25 miles per hour. Shanice is 15 miles per hour. Let's stop here for a question check. Who wants to know where the 15 came from? Okay, so question A is asking us at what rate does each biker travel? A lot of you are still missing keywords and questions on tests and quizzes. If it's asking for each biker, I have to include both people in my answer. Okay, so let's take a look. So let me extend this up. So Brian travels at a rate of 25 miles per hour. The value of the ratio, 3 to 75, was 1 to 25. So Michael, this answers your question. I did 75 to 3. They did 3 to 75. And that's okay. Shanice travels, so we took our information from up here, put it into sentences. So remember to use this page as a reference when you're doing your homework tonight. Have this out next to your homework as a model to sort of copy it. Just change the names and change the numbers. Okay? Like when you watch those crime scene shows, the names have been changed to protect the innocent or the guilty. Well, here it changed. No? Okay, never mind. Anyway. All right, now, I know if I was Shanice, I would totally want to beat Brian. Because I just want to win. I want to improve. I want to do better. So she wants to beat Brian. So, Shanice wants to win the bike race. Make a new graph to show the speed Shanice would have to ride her bike in order to beat Brian. So what speed would she have to go? Let's go back and look. If Brian, what was Brian? 25 miles per hour. And Shanice was what? 15 miles per hour. So how fast would Shanice have to go to beat Brian?
Should I have to double her speed in an hour?
Well, she could double, but that would be a pretty tough task to double it. What would be another option instead of doubling? She just has to go a little bit faster. She just has to go a little bit faster than Brian. She doesn't have to go twice as fast. So what would be faster than 25 miles per hour? 26 miles per hour. She would just have to go 26 miles per hour. That's still a big improvement that she would have to do. All right? Now, they wanted you to make a new graph. We don't have that much time. But look at this example. What did they do? They have Shanice going 30 miles per hour. Just because that I think would be easier to graph and for your table. But on a test or a quiz, this isn't something that would show up on a test or a quiz. But if it would, I would accept anything from 25.1. Anything that's greater than 25 would be a correct answer. Okay? So at this point, if you take a peek at your homework, I'm going to stop the recording. I just want to show you what I'm looking for on your homework.